I'm Brent Jeffries with Bierer Meters. I've been with Bierer Meters for about 8 years now. We're a family company. We build all these tools from scratch that you see here in South Carolina. That's where I come from. That's where the trailer and truck come from. And so Walter Bierer, my stepdad, he's the owner of the company. I call him my dad. He's raised me since I was a little lad. And so he's my dad. My brother works there. We have my nephew, aunts, uncles, my brother's wife. So we're a family company. We build everything from scratch. The diodes, the circuit boards, the resistors, all the soldering. We do everything in South Carolina. So we are truly a USA family company. So it's kind of cool. We're like one of the very, very few out there these days. And if you have any needs for any products, Kaveh can set you up. We have a 60-day tool trial. You're going to find out we have some tools you guys don't know about later on today, and you guys are welcome to try them for 60 days. That's fine. And if you like them, great. That's wonderful. If you don't, send them back. Okay. We have if you go to YouTube, Bierer Meters YouTube videos, we have a lot of videos on YouTube that you can have and download and share with one another on all of our tools. So you go to Bierer Meters tool training, the tool, whatever the name the tool is. We also have Bierer Meters safety training on YouTube. It's all free. You go to the safety tube channel, Bierer Meters, you can sign up for it, and you'll see the videos as they come about. But you go Bierer Meters safety training, subject matter. We got a lot of safety videos. We should have doubled as much as we have today in about end of this year, because we're getting huge in safety right now. So I'm Vice President of Field Operations. That's why I'm in the field with you guys today. And I go around and I do safety training and speaking for the company at statewide associations, the incident prevention conferences. I just, whoever wants me to speak at a particular, like an annual or something, I'll show up and give a speech. So for 6 years that I've been with Bierer Meters, what I've been doing is what you're going to get today. This is kind of a refined, evolving thing that we're doing, and it lasts about 2 hours. Anyways, real quick, there's a lot of things that Bierer does that you all don't know about. And this pamphlet right here, three pages, it talks about Bierer USA. It's Bierer Utility Support Assistance. There is no cost in this. This is not about selling anything. We give service for you guys for free. If you have issues, if you need some field training, we'll fly out, we'll meet you guys, and we'll help you all. There's no cost. Me being here today, none of you guys paid me a dime to be here. This is free. We spend about $1 million a year in safety training around the United States for the last 6 years, and no one pays us a thing. We give back. Bierer gives back. So we're very fortunate because we're a family company. We don't have to put money in stockholders' pocketbooks. We go ahead and give back with some extra profits. Okay, that's how we work. All right, so a year ago, I had a great idea that was given to me about a year ago. So I went to the best speakers in the United States, the safety directors, safety trainers. They go to the IP conference. They do a lot of consultation, things like that. Danny Rains, Jimmy Vaughn, the best of the very best. And I told them my idea about a year ago. And I told them, I said, here's my idea. You guys are going to come to South Carolina. Your company is going to pay for it. Not you, but their company. They're going to pay for it. And you're going to come out for free, and you're going to speak. I need one of you guys to come to South Carolina and speak once a month, and we're going to do monthly lineman safety national webinars. You guys pick the topic. We'll videographer it. All the members get them for free. You guys don't pay nothing. This is Brandon Wiley. He's coming next week. Grab these flyers. There's no cost to this. You get the live line link. Afterwards, anybody that registers to ECAUSE, it's Electric Culture of Safety. That's what we're calling it. We're going nationwide with it. And the reason why we're going nationwide with it, and we're going to talk about a lot of safety, is because we go over behavioral situations out in the field, how we behave, how we act. And the incidences, the small things the near misses, things like that, have gone down. You can research this. But the large incidences where people and the folks are losing arms, legs, hands, fingers, body parts, or death has flatlined for the last 20, 30 years. You all know that? There has been no change. Okay, so this is open forum. If anybody has any questions, feel free to ask the questions. Typically, I'll answer your questions prior to me finishing a subject. If it looks like I'm skipping your question, please interrupt. It's important that you guys understand. All right, so what we're going to talk about is your temporary protected grounds. If you go to OSHA 1910.269, OSHA, Brady Hansen, anybody knows about Brady Hansen, his training throughout the United States? He's a smart dude. And he's got some good training. So if you guys ever want somebody that's really good, he's one of the guys that speaks at Electriculture Safety. I got one of his videos. It's great. The passion behind the idea. It's a good one. But he calls OSHA 1910.269 the scriptures for linemen. And what these are rules. These are rules that are basically considered baseline, a starting point, a foundation to build from. And that foundation that you're going to build from is called safety. And then your company adds to it. Your company tweaks it a little bit, adds some specifics, adds some details, and you guys train it and you guys do it, right? So this is safety. It's a good idea to go over the foundations, the baselines once in a while as a team, a line team. There's good stuff in here. But if you go to lowercase n is a great subject matter. It's called your temporary protective grounds. And there's a lot of good things in lowercase n. If you go down to number four talks about how the triple lowercase I talks about how the IEEE 1048 and the F855 ASTMs are guidelines for those regs. Okay, they're guidelines. All right, so we're going to talk about some things. Whenever you guys are prior to using your TPGs, it's important to complete a visual inspection. We're going to call your temporary protected grounds your best friend. We're going to talk about two best friends today. This is one best friend. You're all going to take care of your best friend. And to do so, you're going to first complete a visual inspection prior to use. And you're going to verify that there's no bubble jacket. You don't want any crimped cable or smashed cable. You don't want to see any blackened copper if it's visible, or patinaed copper if it's visible. You don't want to see any obvious loose components or cracks on your clamps. You also don't want to see any oxidization on your components, on your pieces, especially the contact points. Those especially need to be brushed and cleaned. They work a lot better, okay? So I've gone around the country over the last 6 years, coast to coast, into Canada, Brownsville, Texas, doing the training. And some of the utilities prior to my visit were not teaching and training their linemen to complete a visual inspection. True story. And the reason why I know that's a fact is because first when they hear it, they kind of freak out a little bit. And then they'll go to their truck and they'll pull some grounds off out of their truck. And a lot of times these TPGs out of their trucks, everything you don't want to see is on them. And that's what you see. Some of the TPGs I've seen around the country have multiple infractions, multiple issues, black copper, broken strands, I mean, on the same TPG. And so if that's the case, they're no good. You don't even have to do electrical tests. You guys test yours every year, annually, that's awesome. But these TPGs that are coming off the truck, some of them are so bad, they fail the visual. So why even test electrically? So you also want to perform a mechanical test. On the mechanical test, you want to grab a hold of your clamps and make sure you can't take them off or spin them off your ferrules. Make sure they're nice and tight. Make sure the cable is crimped within the ferrule, or if you've got clamps, make sure that that ferrule is tight in that. Make sure your cable is tight in the crimps of the ferrule itself. All right? So wiggle it a little bit, make sure it's nice and snug. Make sense? So you guys, you're going to perform a visual and a mechanical inspection on your TPGs. If they pass those two things, they typically are going to be a great best friend for you that day. Okay? So it's real simple. Now on your electrical test, your guidelines that are in the OSHA, the IEEE and ASTM, they say that you're going to electrically test your TPGs. It does not say how often. I think it should say how often. It should be 12 months annually. Some companies go 18. A couple that I've been to go 24. I think that's way too long, but they do. There's a few companies out there still to this very day that do not do electrical test. I don't get it, okay? But you guys do, that's awesome. So let's do an electrical test. You guys could get a little closer, okay? I took a shower a couple weeks ago. So on electrical test, what we're gonna do is we're gonna create and mimic a situation, a scenario, as if you're using them out in the field. You're running an EPZ zone on some lines here, and you're setting that up to protect yourself and the equipment around you. And what you're gonna do is you're gonna go from point A to point B, conductor to conductor, conductor to ground, however you're gonna do it. And typically you're gonna go in a straight line. You're gonna have some droopage depending on how long your cable is and how far away all the components are, that's fine. But what you don't wanna do ever is to create some sort of a coil. You don't want the coil. And what happens is this creates, if this gets hit with a fault current, potential fault current, what happens is it creates a magnetic field and the cable wants to escape from itself. It's like, get away from me. All right, so you don't want a coil. I've done some training. If you've got grounds on your truck reel, on your reel, when you're using them, make sure you run those all the way off your reel, and you're gonna run them out on the ground, and you're gonna run them in a parallel scenario on the ground. No coils. If you got some extra length of cable, you do not want to create a cable coil and then run electrical tape so it looks all pretty hanging in the air. I've done the training and I've had guys after the training tell me, so you mean I can't do this no more? And I said, you just had the training. What'd you see? What did you see? And this is what I want you guys to see. We're going to talk about not electrical theory today. We're not going to do that. But what we're going to talk about today is your electrical reality. Okay? So we're going to prove everything we talk about. That's kind of cool. So in other words, what we're going to do is we're going to give you the knowledge. Okay? We can talk about it, but we're going to show you and prove to you the why. So that way you have understanding. When you have knowledge and understanding, that's what equals safety. Is that cool? That's cool, huh? Okay, so let's try this. We're gonna crank this up. I've got an amp meter here at the bottom. I've got one leg missing. It needs to go in for repairs. So it's got to go back to Bierer Meters. Okay, so we can fix that. But anyways, we're gonna crank this up to about 300 amps. Little over maybe. And I can feel that current in my hands flowing through the cable. This tool this is Walter Bierer's first tool. He's got 17 patents now. We have more patents than any of our competitors and all the competitors combined. We have more. It's kind of cool. He's very smart. I just talked to him yesterday on my way here. Said I was going to see you guys. And he says, man, Bierer Meters has never been there in El Centro. That's a great thing. He really likes the safety that we give to you guys. He is very proud of it. And he's glad that we can do that, afford to do it. So I want you guys to see this current. I want you guys to see this magnetic field. Here's the why. See this magnet? This creates a magnetic field, which you don't want. So we're going to go right here into the coil, and you all see that? You all see that? Okay, that's the why you don't do this. Okay? And then what we're going to do is we're going to create a parallel scenario similar to when you're using them in real life, safely. Same magnet, same current, smooth. Little vibration, a little hum, but it's not going all crazy. All right? So remember, when you go home tonight, you get with your lady, or you get with your man, don't go in all coiled up. Huh? Think about it. Be smooth. Be smooth. Huh? Suavecito. Huh? Okay. Any questions about the TPGs? Good? Okay. All right. So what we're going to do is, you can get in the middle now. Melissa. What we're going to talk about is your voltage indicators. The safety, and you guys could kind of spread out now if you want a little more over here too. And that helps break up the arthritis. So we're going to talk about your voltage indicators, corded or wireless. Now, the safety that you're going to hear today, you all need to understand, you're going to hear some things you haven't heard before. Okay? And that's good. And what you're going to want to do is know that in your mind, that every one of you guys are very significant. All of you are very significant. You have a great amount of purpose and in your life, regardless of what title you have, regardless of what you ever do in life, you will have a lot of influence on folks. You will. And it's important when you see one of your brothers or sisters working out in the field unsafe, or your family at home working unsafe, your kids, all right, your wife on the ladder, all right, make sure that you all talk to each other, pause, and have a discussion. All right, if you see somebody working unsafe, say you're any apprentices here? What's your name, sir? Emilio? 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 No, Emilio? Okay, Emilio. If Emilio sees a foreman, if Emilio sees someone that has been in line work for 20, 30 years, and he sees something that's unsafe, Emilio has every right to make you pause. Emilio has every right to make you stop doing what you're doing and have a discussion with you and just make you pause with his words and talk about it. And then after, and you don't have to like what he says, but Emilio has the right to say something. If he sees something unsafe, Emilio has the right to say something, and you have no right to argue back with him because he is your keeper. You all get that? He has every right. Every job, all day long, he has every right. Emilio, can you glove up? You have rubber gloves?
Yeah.
They here?
No, they're my truck.
Where's your truck? On the line? Can somebody get Emilio some gloves? Okay? And a hard hat and safety glasses. You can help me. Not yet, though. Okay? Not yet. All right. So the safety you all are going to get today is irregardless of which tools you ever use. If they're Bierer tools or another manufacturer tools, the safety is exactly the same. There is no difference on how these tools function. It's just that Bierer tools are better. But I can't talk about that, so I won't say they're better. Even though they are, I won't say it. So we're going to talk about safety. So what we're going to do first is a battery test. If you ever use a, perfect, Emilio. If you ever use a Hornet light battery test, you want to see and hear. I don't believe you guys have Hornet lights here, do you? Good. That's great, because I really don't like them that much. But if you ever go somewhere that has Hornet lights, Push button maybe. Ours is always a switch plate, as you know, battery test. But if it's a push button, know that the battery test is only a battery test. It has never been a true tool functionality test. It only tests the battery. There is no transformer inside stepping up 9-volt battery to high voltage. So it's never been a true tool functionality test. Remember that, just a battery test. If you don't see the lights, you don't hear the horn combination, put a new good battery in it, a known good working battery, undo the quick change, tap out the battery, put a new one in, put the quick change back on, retest. If it's still no good, ship it to us for repair. Okay? An analog. I think you guys have some analogs out there of ours, right? Okay, so an analog, a battery test, you want to see that needle deflect all the way. If it's partial or does not deflect, put a new battery in it. If it still doesn't deflect all the way with a good battery or it's partial, send the tool in for repair. It's broken. Real simple. All right? Okay. Also, it's important to wear gloves if your hands get cold. Okay? You could get frostbite here in El Centro, California. So, a digital is simple. You're just going to look at the voltage actually of the battery. So I like digital for a couple reasons. Better. One is they give you more information. So seeing the deflection, the needle deflect on the analog, that's good information. But getting the actual voltage of your actual battery, that's better information. It's more information. So that's what the digital does. 8.3. Okay. 8.3. Everybody see that? If it's 7 volts or less, replace the battery. Our operating instructions say 8 volts. I go to 7. Still works great. If you're seeing 7.2, go ahead and replace it because it'll probably go to 7 before you're done using it that day. So just replace it. Okay? All right. Also, the digitals are more robust. They don't have moving parts. If you drop an analog, they're more apt to break than if you drop a digital because there's no moving parts. Get it? Okay, simple. Simple stuff. All right. It's also important to remember that your tools, the voltage indicators, there's a line limit right here. Y'all see that little line? It's a little teeny line. But that little teeny line is going to remind you all that right here, the 2.5 inches at the end of that probe tip is where the resistors are. Okay, you're always going to remember that. Those resistors help protect the tool from primary voltage. Okay? And ultimately helps protect you behind the tool from primary voltage. Sounds good? So you're always going to remember that those resistors are there. You're going to keep your probes clean. We don't want grease. We don't want paint, markings, calibration stickers on your probes. The reason why is you could have external tracking from the source to the meter head. You don't want that bypassing your protection, your resistors. You don't want that. Hot stick wipes work great. Keep them clean. Take care of them, and they'll take care of you. So that line limit, what you're going to do in your head is you're going to create a sphere, and you're going to take that line limit and you're going to create a sphere all the way around the tool, front, over the top, around the back, underneath, a big sphere. And in your mind, you're going to create that sphere, imagination, and that's going to be your air dielectric. The air dielectric, we're going to talk about her a lot. She's your other best friend we're going to talk about today, air dielectric. So remember this, all right? And that air dielectric, what you don't want to have is you don't want to have a ground plane near the meter head, okay? Next to the meter head. Maybe you're in a tight vault. Maybe you have a bleed wire that you inspect prior to using your tool, you have a bleed wire, and you don't want to have a bleed wire close to the meter head because you could have an arc flash. You don't want to have another hot phase. Maybe you're working substation. I saw a big one going down the road to the hotel last night. What, east to the southeast. That was cool. Some equipment, looks like they're going to do some more work. Anyways, so you don't want another hot phase either. So if you make contact with X, X is going to be your conductor. You don't want to have another X inside that sphere because you could have a crossover, right? Arc flash, boom. Okay, 2 potentials, and you're inside that sphere of protection. You don't want that. So when you're using your tools, we're going to talk about a few things. There's an equation that you're going to learn right now that you haven't heard before, and this equation is an equation that you always need to remember. And you're going to share this equation with folks that are coming up. We're all good? Folks that are coming in. Nuevo Emilios en todo el país. Huh? Okay? Necesito hablando con ellos. ¿Qué pasó con esta ecuación? All right, and the equation is, this is important, guys, is X is your conductor. You make contact with the X, right? Plus Y. Y is the tool functionality. The Y is the why behind the tool. How does the tool work? How does it work? You trust this with your life. Hot or not. In phase or out of phase. How does the tools even work? So here's how they work. Everybody's. They make contact with the conductor. The tool couples with the capacitance that's on that energized source, point source or long source. Don't matter. And it couples with that capacitance. The tools look at the current. They got eyes inside. And it's called components. These components, when they look at the current, they're energized. So the tools, in order to give you what the tool's going to give you on this side, the tools must be energized, correct? So they are energized. Some linemen don't know that. That's how they work. They have to be energized, not with the primary, but because you have the resistors, but they are energized. Much smaller amount than that primary, but they are energized because they got to look at the current in relation to, right here, the ground plane. Okay? They have to look at the current in relation to the ground plane. Now remember, these tools, when it's looking at the current, they're energized, and it's looking at the current in relation to the ground plane. It's going to give you the voltage indication. So X plus Y equals. And the first thing that it equals is the first thing, that's the most important thing. It never has equaled the Z equals Z. X plus Y equals Z. The Z is, first, safety. Okay? It's not, first, what you're looking for here at all. The Z equals safety and accurate information gathering. So X, the conductor, plus Y, the tool functionality, equals safety and accurate information gathering. That's the Z. You all get that? Okay? Always remember that with anybody's tools. So when you're using these tools and you're back on your stick, you do not want to use these tools short sticking. Ever. This is called what we call short sticking. And what happens when you short stick, if you do short sticking, you got to stop. Because this has never, X plus Y equals, this has never equaled safety. Never has. Because what's happening, remember, they're looking at the current, giving you a voltage indication in relation to the ground plane. Well, if you are in here short sticking, then what happens is, remember that we talked about that air dielectric, that sphere? What happens is you're encroaching in that sphere and you become the ground plane that the tool's looking at. See how that works? So what you want to do is train minimum, you're going to be a minimum of 31 inches back from your meter head, regardless of manufacturer. Minimum 31. We recommend 36 inches. 36 inches is more where utilities are going to and training. And you're going to have a handguard, or some guys say, hey, we can't afford handguards. We just get some electrical tape and wrap it around the hot stick, and that's our 36 inches. We stay behind that. Okay, fine. Whatever you want to do. But somehow have it marked so you remember your training. You remember. So what we got to do is we got to make it safe to fail safely, right? So don't just train it and then you're going to guesstimate how far back you are with every time you use your tool. Train it, the reasons why behind that training, the understanding behind that training, and some physical thing to remind you. And when your partner is up in the bucket, you on the ground, Emilio maybe not climbing yet, okay? He's on the ground, but he can verify that his foreman or that journeyman lineman is behind that 36-inch mark. That makes sense? It's real simple. Make it safe to fail safely. All right? All right. So stay back. You don't want a short stick. Don't want a short stick at all. You also don't want a tool glove. Maybe you got gloves on. You don't want to put your tool in your gloved hand. You all use capacitive test points on your elbows? Do you? Capacitive test points on elbows? Some do? Some do? Okay. We're going to act like you all do, because some do. All right? It's not like a soda, Mountain Dew. Some do. Okay? You got to make sure you know what you're talking about. Okay, so you don't want to go to a capacitive test point or a conductor with anybody's device in your hands, gloved hand. Like that. Now the tool's what? Looking at what is a ground plane? Right here. That never has equaled safety, and it's not proper information gathering at all, because you're not away from your tool. These tools were not calibrated. In our calibration room in South Carolina, was somebody holding the tool with their gloved hand, sticking it in some high voltage and calibrating the tool. That's not how we do it, because that's not how the tools are designed to be used. We also don't calibrate our tools with somebody on a stick short sticking, because that's not how the tools are designed to be used. They're designed to be used with you all behind it. Air dielectric. See that? Air dielectric. That's my protection. You create an air dielectric here, that protects a tool. You're going to create an air dielectric here, that protects you all. Make sense? Okay? It's very important. All right, so this is a corner pole right here. That's a corner pole. Does that look like a corner pole? Kinda. All right, that's a corner pole. So I get a call from a lineman in northern Illinois several years ago, and he told me that he's using an analog. He's using an analog, and he's getting 13,000 volts on his analog on 7200. Now this is, Emilio, this is important you remember this. This is a lead lineman, not an apprentice. And the lead lineman for all the other linemen, so he's a shepherd of the sheep. He's having issues with our tool. Calling up and saying the tool's broke, it's not working right. He's on 7200, he's getting 13,000. Well, if I'm phasing, if you all are phasing, phase to phase on 7200 and you're out of phase, you're gonna get close to 13,000 volts. So I already know what's going on with this guy. So I said, look, I'm not gonna argue with you. I'm gonna go ahead and get a plane ticket, come out and give you guys what you guys are getting today, lineman safety and tool training. I did the class, hour and a half in the class. We go out, he gets in the bucket truck. The same scenario, the bucket truck is in the same location. He's using the same broke tool. He gets up, here's a corner pole. I got 3 phases here. I got 3 phases here. And I'm in the bucket truck. And I'm back, he's back on the bucket. He gets that broke tool. He makes contact with the conductor. And he gets about 7,400 volts with the broke tool. That's pretty good for an analog, pretty accurate. So the tool got healed. Think about it, the tool was healed. It's a miracle. Okay? Sometimes there's miracles that happen in northern Illinois. It's not always here in El Centro, but there too. All right? So when he got out of the bucket truck, he proceeded to tell me what he did wrong. The lead lineman, what he did wrong. And what happened was he told me exactly what I already knew. He told me that when that day he called me, he had that tool, he had his back to those lines. When you're working hot, you always and must consider that those conductors are your enemy. Period. They're your enemy. You don't work 20 years as a journeyman lineman thinking you're a lead lineman now so you can put your back to the enemy. No, you got to be like Emilio. Emilio knows you don't put your back to the enemy. He's going to go ahead and have proper body position, and he's going to look at that enemy in the eye. You see, that's proper body position. Enemy at the back is improper. And he was short sticking. So that's improper body position times 2. Back to the enemy, short sticking, improper body position times 2. Okay? After the class, he understands improper and proper body position in relation to his components around him, his job site. And every job site is different from the last job site, even if it's the same equipment. It's in relation to all the things, how close they are, how far they are, the environmental conditions, the roly-poly rocks. Maybe you're working, you got some grass around well, not a lot of grass around here, but maybe some sand dunes. Okay, so you got different things happening during the day. And these different things play a part in your life at that very moment. In your life, that you're trying to live and try to watch out for your fellow linemen so they live too. So you got to be aware of these things. So then he simply got in the bucket truck and he had the enemy to the front. He created an air dielectric so he had proper body position. And he got 7,400, okay? Another guy called me up. He had a horn and light, like right here. He had a horn and light. And he said, hey, my horn and light is giving me a false positive. He said, I got the switch open. And he said, it's a visual air gap, lockout. We got a tag out and everything's good. And he said, I'm getting a false positive on this conductor. So I said, show me the video. Show me where you're at. He calls me up, switch is open. He's on a corner pole, and he says he's getting a false positive with our tool. So I asked him, did you do the battery test? Yes. I asked him, did you test the tool prior to use on a live known voltage source? No, we don't do that. And I said, well, how do you know the tool's working or not if you don't do that? So they do that now. His utility, they do that now. Always test your tool on a live known voltage source. We're going to talk about that more in just a minute. So he did. And after he tested on a live known voltage source, it was accurate. I could tell it was calibrated because it was working accurately. And I could tell everything about the tool was fine. I told him everything about the tool is fine. He got upset. He says, no, your tool's broke. I said, well, let's do the video. So he's in the bucket truck. Here's the corner pole. He touches that de-energized conductor. He's got his back to the enemy. He's short sticking. And that conductor, the tool's saying is hot. So let me ask you something. The switch is open and the tool is telling him that that conductor is hot. Is it hot? Was the tool telling the truth or fake news? It was truth. Because his back was to the enemy, his body was coupling with the capacitance of that energized source at his back. And it was flowing across his gloves. He was using rubber gloves. It was flowing across his body, through his body. Think about that. Across his gloves, through the tool, the opposite direction that the tool is designed for. And the tool was telling him that that conductor was indeed energized. And it was, through his body. See how that works? Okay? So after the quick instruction, FaceTiming, he gets proper body position. He creates an air dielectric between him and the tool. And the tool's looking at the ground plane here, right there, not him. And he touches the conductor, and the tool's silent. The conductor's de-energized now because he has proper body position. Had nothing to do with the switch, everything to do with the switch in his head. You see how that works, guys? You got to have the proper switch. If you're going to lock out and tag out at the job site mentally, you're not going to be energized with safety. Okay? We're going to backfeed these pad mounts with 12208. We're going to come out the front with 19.9 Okay? So we're backfeeding. And we'll come out with primary power. Yep. Okay, everything's working. All right, so what we're going to do is we're going to go over safety, whether you're using your analog, whether you're using a digital. Do you all have corded digital device as well? No? Do you have the wireless phaser? You have what?
Substations. Oh, we have that one.
The corded? Okay, cool. So good. We'll talk about wireless phasing. We'll talk about corded phasing, wireless safety, and corded safety. Now remember, the tools, when they're energized, they couple with the capacitance of the conductor. They couple with it. They look at the current relation to the ground plane. Wireless through the air. If it's corded, it does the exact same thing, but through the cord to the ground plane. See how that works? It's a direct connection to the ground plane, but it's through the cord, but it's the same principle, how they work. Okay? So, I like to train. Do you have any tool that has the proximity setting to where you can approach an area in proximity just to verify it's energized or not? Something? You do? Good. You do? Okay. So what I'm going to do is for the safety is I'm going to use the the VD1000P. It goes up to 999 kV. And you've got the P setting for proximity. Now our tools, we're the only manufacturer that builds a tool that discriminates. It discriminates whether the tool and you are working close to the ground plane, which is URD, underground, or if you're working far from the ground plane, overhead, or if you're on some transmission, OHT. We're the only company that does that. The reason why we do that is because we know how these tools function. The other guys haven't figured it out yet. But we did. Okay? So we discriminate. So what we do is we use the P setting. I like to train this to where if you're in a situation there's lines down, a line on a car, you got some storm damage, it's dark outside, you're approaching a work area, maybe you're driving the line and you just hold out the window and watch for those numbers to go up, then you got an issue there. You can just hold it out the window. It's very sensitive. But what we're going to do is we're going to use it to approach our capacitive test points. So I got it in the P setting. We just want to verify this. Say this is a three-phase cabinet. Three-phase cabinet. It's cold. My lips can't move. All right? And we're just going to approach just to verify if one of those phases are energized or not. That's all. We're not concerned about which one. Or we're at dark outside and you're walking through the dunes and you got some bushes and you don't know where that line is. Just hold it in front of you and kind of walk and look for those numbers to go up. All right? If you have dust caps on, or if you have elbows without capacitive test points, or if you have capacitive test points and dust caps, you can keep the dust caps on and go to the base of the elbow. And it'll sniff it out. The base of the elbow, because the semicon material at the base of your elbows. See how that works? It'll sniff it out. Okay? Now this is three-phase overhead line. Okay, looks like it anyways, right, Emilio? Okay, close. All right, so what we're doing is we're going to hold this stick up, and we're just going to go to that three-phase overhead line and verify if something's energized or not. That's all we're doing. Well, that's pretty cool. Do you guys get this all the time? Is that what that is? They practice? Oh, I didn't know that. You guys teaching me something. Wow, that's cool. All right, here we go. So we're going to approach this overhead line. You all see that? One of those phases we know for sure is energized. Okay? We don't care which one. We're out in the field. We just want to see if something's energized as we approach. It's dark outside. I can't see. Maybe you got that once a year rain that you guys get. Okay? And you just want to hold that in front of you as you walk. Okay? That's what you do. All right? But prior to doing work, you always want to make direct contact. If you ever go to a company that uses non-contact devices, you need to talk with the safety guy. You need to talk with the tools guy and tell them that they got to throw those tools away. Because they'll give you false positives, false negatives. If you're on an underbuild, they just give you information that you've got to be a little presumptuous from time to time. And sometimes you actually got to be a good guesser. And linemen cannot afford to be good guessers nor presumptuous. You want a direct contact tool to where you want to know for sure without any doubts what is on that conductor. Is it really de-energized or not? See how that works? So no non-contact tools. I did a speech for a company in Syracuse, New York last August. They wanted me to come up and do a safety speech. Okay, fine. So I went up there and did a safety speech. After my speech, the safety guy calls me 2 weeks later and he says, hey, you gave a safety speech and you told my guys that we can't use non-contact tools. That's right, I did. Well, that's all we use. Oh man. Well then, are you guys gonna chunk them? And that's a term I used when I moved to South Carolina, chunk them. It's one word. I didn't learn that in Arizona, but the word chunk them in South Carolina means to throw it away. Okay? And yeah, you guys got to throw them away. And they did. And now their linemen are more safer. They have direct contact tools, happen to be ours. That's kind of cool too. But their linemen have better information. They're a lot safer. And that makes me feel good. All right? That's a good thing. All right, so we're going to put this tool, we're obviously close to the ground plane. So we're going to put the tool in URD. Right there, underground. Okay, because we're close to the ground plane and you guys know how these tools function. So we come to that capacitive test point, direct contact. Because this three-phase cabinet, we only want to work on the middle phase. We don't care about the other phases. We want to de-energize the middle phase. So this is cool. We want direct contact and the tool won't be influenced by the other two phases. Just the one that we're going to work on. Direct contact. Y'all see that? Whoa. See that, Miss Melissa? You see that? Got that? Okay, good. All right, you all see that? Direct contact. Always go direct contact. Okay? So we got this overhead line right there. Now it's important that on your cone tip, on your tools, anybody's tools, that you're always going to use the proper accessory. You do not want to take a shortcut and just use the end of your tool. For instance, you needed a straight probe to make contact with that capacitive test point. You don't use one. If you don't use one, a little straight probe, you're taking a shortcut. And that's not safe. If you're out in the field, you got an overhead line, you're going to use a hook, straight probe, something, but not just the tip of the tool. That's a shortcut. You got a feed through, you got a hot bushing, you're going to use right here, bushing adapter. So we got the tool in URD. This overhead line is obviously close to the ground plane. So we're URD. make contact, direct contact, and those numbers are not moving. Remember? We had them proximity and they were moving. Well, now we got a direct contact, they're not moving, and that's what you want. You already know something that conductor's energized, so that's fine. But direct contact. There we go. About 20,000 volts on a 19.9, so it's pretty accurate. Wireless. Pretty accurate, great tool. So you can use it proximity, you can use it in direct contact. Okay? So, what we're going to talk about is something that's super important as well. And this is a good safety thing that you must remember. Where'd it go? There it is. In the training that I do around the country, it's really cool and it makes me feel good that this is like wildfire going across line crews, what you're about to hear now. If you go to 1910.269, talking lowercase n, talking about your TPGs, again, your best friend. Prior to installing your temporary protective grounds, you're going to use your tester, number 5 says so, lowercase n, TPGs, number 5. You're going to use your tester, whoever it is, doesn't matter, and verify that there's an absence of nominal voltage. That's what it says. Okay? You're going to look for an absence of your system voltage on the conductor prior to placing and setting up your EPZ. All right? But you guys have tools that are accurate enough that this is how you're going to train it from now on. You're going to use your tool to verify an absence of your system voltage, an absence of induction voltage, and an absence of backfeed voltage. All three. All the time, every job, no matter what. That's how you do it, and that's what needs to be in your mind. Guys are getting hurt on induction. Some guys are dying and getting killed on induction. Okay? This is very important. So your tools are accurate enough. That's why I don't like non-contact tools, because they're not accurate enough to verify an absence of induction, an absence of backfeed, and sometimes your nominal voltage. Maybe you're on an underbuild. They'll get all messed up because of all these different components, all these different fields that are getting into that tool and messing the tool's brain up. Okay, because its brain is very small. Okay, it's a cockroach. Cucaracha. Okay, all right. So just remember that. Your tools, you're going to always verify a lack of all three voltages. So in April of last year, Lito Wilkins came to South Carolina, International Line Builders. He works in California in the Sacramento area for International Line Builders. He came to South Carolina and he gave a speech. And you guys can have the video. Just ask me for it. You can have all the videos. And in this speech, he talked about, he called it My Shocking Awakening. And what happened is several years ago, he was working on a crew. And what they were doing is they were on the tower. They were working with the helicopter. And they were changing out bells, the insulators. They were changing out bells on some of the towers. And they were on the ground, preparing the plan, doing the tailboard, going over the job briefing. And when they were talking on the ground, they noticed that there was this cable that was on the tower that was going down the length of the cable, all right, the leg. And they had a little concern, but you know what? They were okay. Let's just go to work. We're good, all right? It was the first day that they had fall restraint. First, now I get these stories that are happening out there. They're not just crazy once a thing. How could this ever happen? They are happening. And this first day they had fall restraint. And you know they went up on that tower with fall restraint in the truck. They left it in the truck because they didn't practice. They weren't comfortable using it. So they did not use it that day. The very day they first had it. They get on the tower
Mr. Lido, he's walking. He's a cool guy too. He's a good friend of mine now. He's walking across the tower, and he's got his leathers on or whatever he's got on, and he grabs a hold of that frame of that tower to get across to the other side. Grabs a hold of the cable, and he can't let go. The induction froze up his muscles, contracting, and he couldn't let go. And immediately, he knows what's going on. And in his mind, time slowed down. It's weird how things happen when you're going through something that's so traumatic. And it's like time slowing down. And in his mind, he's thinking, if I keep hold on to this, I'm going to die. And the cycles, what is happening is that induction was going through his body, blowing out his wrist, blowing out his lug on his boot to ground on the frame of that tower. And as it did blow out, it would bleed off through his body, and he was able to kind of let loose a little bit, but then the cycle would come back and he'd have to grab back on. And he knew that the only thing he could do is let go at that one moment and literally and purposely fall backwards. No fall restraint. It's in the truck. And he knows that if he keeps hold of it, he's going to die. If he lets go and falls backward, he's got a very good chance he's going to go to the ground and he'll be dead too. But there was some angle iron behind him that he was hoping would cradle him when he did fall on purpose. Think about it. There's angle iron right there. And he literally let go and he fell back, and that angle iron cradled him just enough to where he didn't go to the ground and die. True story. Now he's the international lineman safety guy. He's got inspiration, but you don't want that inspiration, guys. You don't want that inspiration to be the safety guy. Okay? All right. So what we're going to do here is we're going to train this. Instead of open test ground, all right, we're going to talk about something else that's sweeping the country. We're going to go ahead and we're going to test first. We're going to test first. Why? Because we want to take our voltage indicator and test on a live known voltage source. So we're not going to open first. We're going to test first. And it takes a little more time. In order to do these 5 steps, test, open, test, test the tester, ground. In order to do these 5 steps, Emilio and I, we cannot get our 10 jobs done a week. Because Emilio and I are safer than the standard minimum foundation of what the industry teaches. It takes me and him longer to do our jobs. But we can only do 9 jobs a week instead of 10. But Emilio is going to retire, an old guy with Imperial Irrigation District. I'm going to retire an old guy at Imperial Irrigation District as well. And we're going to be happy, and we're going to have all of our body parts. So, me and him, we're going to go a little slower. Slow is smooth. Smooth is fast. And we're always going to be safe. See, we can get 10 jobs done, but what happens, Emilio or I, we're working fast. We're trying to get this job done. In our mind, we're guys. So guys like to go fast and produce. We're just built like that. We just, we work and we want to work. We want to do things, get things accomplished, and get to the next job. They're paying us to do it, and that's what we do. So what happens is you guys are down a few guys on your crews. You're looking for more folks because you're a little bit small on your workforce, and you need a few more guys because some of these older guys are retiring and leaving. We got a vacuum we're trying to fill with young folks, so we're trying to push them out and get them trained and get them out and go to work. Okay? That's dangerous, man. A lot of these folks that are dying nowadays, they're apprentices. They're apprentices, okay? Because they just don't have the practice. They just don't have the experience, and they're getting on these lines that they're not quite ready for, and maybe the guys that are with them aren't watching them as they should as well. Okay? So what we're going to do instead of open test ground is we're going to test, open, test the tester, ground. 5 steps instead of 3. Okay? So what we're going to do is we're going to go ahead and test first. That's what we do. And the tool's telling us that that conductor, that overhead line, is energized. But it's also telling us that the tool is pretty close to what's on that system voltage, so we know the tool's calibrated, working properly. That's important to know. But me and Emilio, we do this. The reason why we test first as well before we open the switch is because Emilio and I, we got it on that tailboard, that job briefing, we sign it. We sign it, right? You guys sign it? Okay? You guys sign it. But we're going to add a line to it. And that line that is on that job brief that you're going to sign is also going to say, in addition to what you're used to, it's also going to ask you the question, are you personally accountable to me this day? Me and Emilio. And there's going to be a checkbox, yes, and you're going to sign it. It's also going to say, are you going to be mutually accountable to me today? And me and Emilio is on this job site, this overhead line. And we're going to talk about it. Emilio, are you going to be mutually accountable to me today at this job site? Yeah. Okay. And then he's going to ask me the exact same question. I'm a 30-year journeyman lineman. How many years you been apprentice now, Emilio?
2 years.
2 years? Okay, cool. You're about halfway. What are you, 8 step now? No? 3? Where you at?
2 years in.
Okay. All right. So Emilio, he's 2 years in apprentice. He gets to ask me the exact same question, a 30-year journeyman lineman, the exact same question. And I have to be just as responsible in my answer to him as he is to me. Because when you talk about safety and watching out for one another, there is no such thing as titles. There is no such thing as experience. What it is, the such thing that is, it's a culture of safety. It's a mindset of safety. And it's safe for him to ask me. And I'm not going to get upset about it at all. Because that's our culture. That's what we do. So we test first. And then what we do, after we test, we verify our head's in the game at the job site. We're going to open the switch. All right, we got a visual air gap, confirmed. We lock out, we tag out, we're good. And then we test. All right, we test, and the tool tells us 3 things. Remember, 3 things. There's no nominal voltage on that conductor. There's no induction, and there's no backfeed. We always got to think about those 3 voltages, and I think the regs need to be changed. I think they need to be changed. Number 5. And say that. Okay? So it's a lack of all 3. And then what we want to do is we want to use our tool. And we're going to test the tester. So we got a handheld power supply right here. And we're going to test the tester. All right? If you're on an outage, some storm, and you don't have a known voltage, live known voltage source, 3 kV power supply in your kit, or a handheld power supply, you're going to always test the tester on a live known voltage source prior to use, and you test the tester on a live known voltage source after the tool tells you you have an absence of all 3 voltages. Test the tester. Now we know the tool is telling the truth. The tool was working when it said no voltages of all 3, and now we can ground safely that overhead line. See how that works? Okay? Every time, every job. What we want to talk about now is arc flash prevention with your device. Corded or wireless. Anybody's tools. Ours or somebody else's, it don't matter. So, remember, what we want to do is we want to create a sphere, right? But when you use your tool prior to use, you're going to investigate, you're going to look at your work area, that tight vault. You're going to look at that cabinet. You're going to look at that substation, that conductor you're going to make contact with. You're going to verify prior to using your tool, wireless or corded, that there's not an influence that could come in within that sphere. Maybe the cabinet door, the cabinet wall, a bleed wire that's going to be near the meter head, or another hot bus that's going to be near the meter head. And you don't want that because you know how these tools work. You know they're energized, and if you have a ground plane near that, you could have an arc flash. If you extension, arc flash prevention. Okay, pretty simple. 0 ohm extension, arc flash prevention. This, a lot of utilities are flat going to. APS, I just finished with them yesterday. They're going to do this. I just finished a lot of training in Texas with Encore. Encore went with this. This last year, like 2 months ago. Okay, so 0 ohm extension is arc flash prevention. So what you do by using a 0 ohm extension is you're going to take, I can watch them while I'm doing this. What you're going to do is you're going to make this scenario that you're a possible arc flash, put on your 0 ohm extension, and then you bring your tool, and now that situation is not in that air dielectric, your best friend. That situation is away from that. So your resistors are protecting you, and that ground plane, potential ground plane or hot phase is way over here now. You won't have an arc flash. Okay? So let's look at what it looks like. Here we go. What's that? Yeah, see? He's watching out for me. Here we go. All right. You all see those numbers now? Remember, without the 0 ohm extension, those numbers were a little over 20,000, right? We have the 0 ohm extension, and now those numbers are closer to 18,000. But you know why? Because you know how the tool functions, right? Remember how it functions, the X plus Y. Remember, it's real simple. So now you know, because how the tool functions, you know that the meter itself is further from two things. What two things is the meter further from? Remember how they function. What two things? Nice. The meter is flat out further from the source, and you know how they function. All right? So the numbers lower now make sense. All right? So it's further from the source and also further from, not me, because I'm still holding the stick the same way. Hold on. Further from? Where? Nope. The meter head, the tool, because of the 0 ohm extension, is further from what? The ground source. See? The meter head is further from the ground source. Remember how they work? Source and ground. So with the 0 ohm extension, what we get now is X plus Y equals more safety, because we had a potential here, or we had a ground plane here. So we get more safety and accurate information. You guys get that? Okay? All right. So I was doing training in Tennessee, and these two linemen came up to me in Tennessee, and they said, hey, we had an arc flash. And what happened in this incident that took place was there was two guys working in a cabinet, and the cabinet was loose from its foundation. So remember, whenever you live in your life, you must have a good foundation. Okay? Remember that. And what happened is that cabinet was a little bit loose. One guy was on a stick working the elbows, and they knew it was hot. And one of the guys took his gloved hand, he had gloves on, took his gloved hand and went to the cabinet to hold it, steady the cabinet. And when he did, he got arc flashed. So it was a hot day, sweaty day in Tennessee, and he had swamp britches. Okay? It's like you guys, when it's 115, you're out working, you're going to have swamp britches. Okay? You'll know what it's like in South Carolina. That's what it's like. Okay? And then, so what happened was on that hot, humid day, those red lines, it's not dry. Like today's dry and cool. The red lines are further away. Environmental conditions. But when it's hot and sweaty, those red lines come after you a little bit. The electrons get excited when they see your swamp britches. Okay? And when he put his hand on that cabinet, he got arc flash. Spent some time in the hospital. He didn't lose any body parts. He's okay. He got burned up a little bit. But what happens is, you know, we talked about gloves. Gloves are to be considered, if you're using them on a particular situation, a particular site, are to be considered not a best friend, but a good friend. And sometimes a good friend can let you down. But keeping your air dielectric, that guy that was on the stick, he had his air dielectric from the components, from the system he was working on. He didn't get arc flashed because he had the air dielectric. The other guy did because he didn't have the air dielectric. Okay? See how that works? Okay? So, watch these numbers. I got gloves on. Watch what happens. Okay? Yeah, this is if you guys can't see this, you guys need to see this. Okay, now watch what happens. Are those numbers going up? Are they? Okay. Well, you guys know, remember we talked about, we're not going to talk about electrical theory. We're going to talk about your electrical reality. And when you guys are working out in the field, you guys are coupling with those electrons, even when you're working safe. Even when you're working safe, those electrons, to some measurable degree, are going in and through your body. Flat out. When you're working hot. They are. Every time. But when you're working unsafe, they're really jumping through and across your body. Are they not? Look. Look. See what happens? All right. So in that incident report, what they said is the reason why he got arc flashed is because of rat piss in the cables. So they rat piss. So what happens? It's rat piss. So we don't talk about it no more because that's why it happened. So what happens when you go to a job site? Make sure you don't see rat piss. Okay? So who learned anything about safety? We just swept that situation, that incident, under the rug, and we're not going to talk about it, and we're going to pay out some money. The guy gets healed, he's back on the job after a little while, and we're just not going to discuss how your electrical reality works. And they didn't. So no one learned. Think about it. The guy that got injured didn't learn nothing. The guy that wasn't injured didn't learn nothing, and the whole crew didn't learn nothing. They didn't learn anything about their electrical reality. And the fact is, that story of the rat piss being the cause, the root cause analysis, was completely escape rat. It's not true. Not true at all. Okay? So no one learned nothing. And unfortunately, that happens a lot in this industry, and it's very sad. When I was at Trico in Marana, just northwest of Tucson, last week, and did the training for them, I had an experience that I hadn't seen before. Those guys, it was so cool. And it really, this is where we need to go. Before I got started, they had a 15-minute tailboard. And what they did in that 15 minutes is they talked about safety, and they opened it up for everybody to share without any retribution, without anybody talking down to them at all. And they were open and free. And two guys stood up and they were able to talk about near misses and incidences that took place that week before. And they did. And it was so cool to hear those two guys talk about two different scenarios, two different situations that were near misses And they were incidences that took place with the other folks. And guess what? Those other folks learned from their mistakes. They learned what not to do because they did it wrong. You see how that works? And so they were brothers, man. If your brother makes a mistake, don't you want them to tell you? Or your sister makes a mistake, don't you want them to tell you? So that you learn. And if you learn, you live. Because you have knowledge, you have understanding, and now you get safety. And they did. It was so cool to see. And nobody put them down. Nobody looked down on it. They embraced it. They wanted it. It's the opposite of how we think normally as a guy. Is we don't want to talk about it. We don't want to share it. But if you do the opposite of how a guy thinks, and just be open and be brothers and sisters, then you learn, and they were embracing it. It was neat to see. Great. I enjoyed that. Okay, you ready, young lad? Emilio, ready? Okay, go ahead. You can get your gloves on. Get your gloves on and let's do this, man. All right. So guys, you could, in order to see these readings, you may have to come in a little closer because this is a different meter here. This is a PD25, which is like the PD50. It's our digital. This tool here, if you use it, it's a great tool to use. It's very accurate. It's plus or minus 1% true RMS voltage. It's very accurate. We got a meter and we got the secondary probe. It's corded. This cord, we are the only manufacturer that makes a cord that's shielded at 35,000 volts. No other manufacturer does what Bierer does. Bierer Meters, we custom build this cord, and it's a cord in a cord. That means it's shielded. All right? Nobody else does that. It's kind of cool. So you can use this tool when you're using it. A lot of folks didn't realize it, but you can use this tool safely with the cord on the ground. If you're phasing across a cabinet, the cord can lay on the cabinet, that metal cabinet, when you're phasing. Safely, it can. Okay? We just build safer tools than most folks, that's all. All right, so this tool, because of its accuracy, we call this tool a multimeter. The multimeter, you can find your leading phase out in the field with the phase sequence adapter. You can also high pot with this tool. You can DC trace cable and ID cable because the tool reads AC and DC voltages. All right? So with a 100 volt battery pack on the secondary probe, you can go to your new construction, your underground, get on the center conductor, come through with the PD25. When you see 100 volts DC, that's the cable. You can also de-energize capacitors, de-energize charge on a cable that you just high potted. You can also verify your regulator neutrals in the neutral position. And you can do, what else? Other things, I just can't remember everything. It's a multimeter. This is one of Walter's 17 patents. It does more work than any other meter in the world. Okay, really. So we're going to use this tool, Mr. Emilio. He's going to read voltages on my body. He's going to read voltages when I work safe. And Emilio, I'm going to have you read the voltage on my boot. Okay, so you'll need to make contact when we're ready. And then on my back. And then I'm going to make a tunnel, and you can look at the voltage on my inside glove. Okay? So you guys are trading me safety. I'm very safe. I know that I got to be back on the stick. Imperial Irrigation District teaches me to stay away from the meter to keep the air dielectric, and that's how I do it. That's how I work it. I'm back on the stick. Okay? And then I'm going to work safe. Emilio, go ahead and read that voltage on that boot. Go ahead. You'll have to take it. I'm sorry. Yeah. Go ahead and take the switch to 2 kV. 2 kV goes from 1 volt, literally 1 volt to 2,000 volts. Okay, you ready? Okay, buddy. And make sure Miss Melissa can see that. Go ahead. I'll move up. Go ahead and touch the bolt. Touch the boot, I'm sorry. Hold on, let's see if Melissa can scope on in. You see that? She sees it. Okay, what you got?
18.
Tell these guys, not me.
18.
That's good. Apprentice, you gotta learn, man. You gotta learn to talk to these guys. All right? All right, go ahead and get the back and let Melissa get in on it.
25.
Hey, don't be cutting jokes. Okay?
25.
Okay. Inside glove?
33.
33. All right. So I don't work at Imperial Irrigation District. I'm at this other, I'm working with this contracting group, okay? Because they're paying me good money. So I'm working with this contracting group, paying me good money, but they're not training me as good as they should. Now you think about that. You can work with a contractor group and you can make that real good money, but are you getting that real good safety? I know what's going on out there, and I said that for a very good reason. If you're chasing the dollar, you could be chasing your grave. Think about what I just said, okay? Because I know what's going on out there. Contractors are under a lot of pressure to produce. And when you're under pressure to produce, oh, you're going to have production all right. And what are you going to produce? You're going to have these great big productions of all these bucket trucks coming together and with flags hanging at a funeral. That's what you're going to produce. It's a big stage. It's called learned helplessness. Think about it. You're training to do this big old stage with all your buckets. Oh, everybody's crying, everybody's sad. Because they were chasing the dollar, chasing production, and they weren't chasing safety. This is really happening. And because I'm involved with this right here, all these speakers all around the country, I am very blessed. I didn't realize that this was going to be one of the things that were going to happen to me, is to be blessed with all these dang speakers and all their experience. I get to have it for free. But you guys can too. And I'm telling you, if you're thinking about the money, because you want a bigger this, you want a bigger that, you want more of these or some of them, you are actually chasing death. You are chasing one less leg. You are chasing one less arm on your body. Don't do it. Be happy. Be happy with what you got. Okay? Be satisfied for the simple things in life. Okay? You'll live a lot longer. Okay? All right. So I'm chasing that dollar and I'm short stick. Okay, I got a big 4-wheel drive that compensates for it out there in the parking lot, but I'm short stick. Okay, and that's a horrible nickname to have, Emilio, if you're a lineman, is short stick. Okay? All right, here we go. You ready? All right, don't be looking at me and smiling that much. Okay, you look a little too happy. All right, here we go. Get that boot, Emilio. Get that boot. Huh? Go ahead. What you got? 25? Miss Melissa? Got it? Okay, get the back.
37.
A little higher?
36.
Yeah, okay. Inside glove.
60.
60 volts. Okay? Is that chasing safety, chasing that dollar? Huh? This is a true thing that is happening in the industry. I see it. I hear it. And unfortunately, I get the news. Okay? I get the news because I've got all these people telling me in different parts of the country what's going on. Okay, here we go. So now I'm very unsafe, and I'm gonna go ahead and tool glove. That's a bad nickname to have, Emilio. Tool glover. Okay? So I'm gonna tool glove. Okay? Same thing, buddy. Boot.
74, 75.
Okay?
78.
78. Back.
115.
Okay? Inside glove.
208.
Huh?
208.
208. Was that safe? I didn't have air dielectric, and you could tell I did it. And you could tell that those electrons were getting happy and seeing me and getting excited about me being in their life. Now they're in my life because they want to take my life because they want to go back home. My body and your bodies are from dirt and water. Right here, dirt and water. It's not who you are at all. But for now, who you are is attached to dirt and water. And those electrons, they want to go home. And if you allow them to go home, they absolutely will, without any of your permission or without you saying anything to them, they're going to do it. Because that's how electricity works. That's your electrical reality. Okay? Now watch this. I got no gloves. You guys work with leathers, right? Leathers on your sticks. Watch this. Watch this. Okay? So I'm going to work safe. I got leathers. I don't have rubber gloves on. Okay. Let's go, Emilio. The boot. 18. The back.
25.
Okay. Inside glove.
36.
36. Were those similar readings than when I had the rubbers on? They were, weren't they? They were about the same. And you know why? Because you know your electrical reality is it doesn't matter if you're wearing rubber gloves. It doesn't matter if you're wearing leather gloves. It doesn't matter about anything. You know those electrons see you. And you know those electrons see this. And when you're working in those electrons are coupling with you. Even when you're safe. Okay? True story. That's just how it is. All right? All right. Any questions thus far? Good? Okay, let's do some phasing. We're going to come over here, Matt. Okay? And this actually is pretty good. Thank you for bringing it up. Because I was supposed to show you and I forgot. It's the second thing that goes. Okay? So I'm going to stand on a mat. Okay? This is super dielectric. So if I put a super dielectric on or stand on a mat, I'm feeling pretty safe. So I'm standing on a blanket. All right, you ready to show? So I'm just going to do tool gloving. Let's just go straight to the point. Okay, on the boot. Yeah, it timed out. You got it?
77, 80.
80?
80.
Is that similar? Back?
135.
Similar, isn't it? Inside glove. Right there.
246.
246. Okay, similar, isn't it? Then what? Yeah, similar. So if I'm standing on a blanket, does that mitigate how those electrons move? It doesn't, because that's your electrical reality. If I'm Gumby, let's say I'm Gumby, does that mitigate how the electrons move? No. When you're working hot, you are actually working hot. More than you could ever imagine. But if you're going to work hot, work safe. Because if you don't work safe when you're working hot, those electrons will go home. They already are going home, but they're going to create that red line that you're going to cross. And then you'll know it. Emilio and I, we're at this new job site. Okay? This is our second job site of the day. So the second job site of the day, new job site, we're going to do the same thing. So what we're going to do is we're going to use our tool and we're going to test the tool on a live known voltage source, correct? Make sure the tool's functioning. We're going to phase here off the capacitive test points. So we want to make sure that the capacitive test points are energized before we phase, correct? Okay, so that makes sense. But the biggest thing that we're going to do is Emilio's going to ask me if my head's in the game And if I'm mutually accountable to him at this job site today, okay? We're gonna talk about it. It was on the job brief, and I signed it. When you sign off on a job brief, you guys never sign off on a job brief. When you sign a job brief, you are confirming that you are in covenant. You are confirming that you're committed. You're confirming that you have an oath with your fellow line brothers and line sisters. That's what you do when you sign a job brief. Okay? You're confirming your oath and your covenant. Emilio and I, we don't even get along. I don't like him, and he hates me. Okay? I got tats, I got piercings, I speak bad, foul language, and I put him down, which I shouldn't, but I do. And he don't like it, and he don't like me. But when you sign that job brief and you confirm your oath and your covenant as a lineman, it doesn't matter who you work with that day. It doesn't matter if he's the golden boy and he's the golden team. He's the dream team. I wouldn't want to dream about him though. That would be weird. But when you sign that oath, that covenant, you're going to watch out for each other, because that's what a lineman does. If you're working with somebody, it doesn't matter if you don't like them or if you do like them. That's where we got to be, in your head. It's not about your feelings towards one another if you dislike him. So let me ask you, does relationship affect crew safety? It shouldn't. And that's where we need to get. But it does. Typically it does. And that's where we need to get away from. If you have a relationship with somebody on your crew that stinks, the only reason why it stinks when you're doing line work is because you're allowing it to in your head. And it shouldn't be in your head. After work, you don't have to like each other. During work, you don't have to like each other. But Emilio, I don't like him, but he has every right to go home to his wife and kids. Do you have wife and kids?
No.
You'll learn one day. He has every right to go to his wife and kids one day. As I do. He knows it and I know it, and we're going to talk about it. It takes us a little longer at this job site to discuss these things, but we're a lot safer because we did. Okay? All right. So, Emilio, go ahead to that capacitive test point on the top. Your H1B. And let Miss Melissa see it. You're blocking her. There you go. And what do you get?
237.
237? Close to 240? Close to 235, I guess. All right, go to the bottom one. Other side of the cabinet.
183.
183. So what's the difference? About 50? 45? About 45 volts, 50 volts difference, something like that. You don't have to be exact. So what happens, this tool's so accurate that if we are in phase, I'll go to the other cabinet. If we're in phase, then we're going to see the difference of the two readings phase to ground. If we subtract the difference, that's how we get our zero, same phase. If we're out of phase, we're going to see a number that's way higher than 300 volts. Okay, our multiplier 1.73 or so. And we're gonna know that we're out of phase. You don't need a calculator. You just see these big numbers. That's a lot bigger than the phase to ground number of any of those two elbows. And we know that the reading from phase to ground on each elbow is a little different. The reason why we know is because we know that the components from that top elbow are slightly different in arrangement with the elbow and the elbow with the ground plane. Does that make sense? The other one is a little different than the upper one. So our voltage readings are a little different. And because we know how electricity works. So that's fine. All right, so I'm going to go to the other side or the other cabinet. The cord, it can lay on top of a metal box. That's fine. We're not worried about that. It's safe. So I go to the other one and go ahead to the top. I'll go around, and what you get?
43.
43. That's close to 45. Do the math. We're in phase. Okay? Real simple. Okay, buddy, let's go to this cabinet right here hanging on the trailer. See right there? Now remember, that's 20,000 volts. Okay, so just remember that. Okay? All right, so we're at this job site. We're doing some commercial work. And maybe 277, 480 or whatever. This happens to be 120, 208. And go ahead, Emilio, go ahead to that upper lug right there. Okay, you got it? Okay, tell everybody what reading you get. Tell them.
118.
Okay, so phase to ground, right? 118, stay there. What you get?
0.
0. Same phase? Yep. Okay, stay there. See, I'm doing all the work, man. Huh?
Well, I'll do it.
What you get?
206.
206, almost 208. See that? So you can phase secondary, you can phase primary, overhead, underground. It's a great, accurate tool. Very safe. All right? Okay, Miss Melissa, we're going to go to the center now. We're going to phase this overhead line right here that you all can plainly see. Right? Now, remember we talked about your TPGs not having them in a coil. Remember that? Because you know it creates a magnetic field if it got hit by a potential fault current, and it would escape from itself. Well, check this out. That's the same thing you need to think about when you're using a corded tool. Okay, this is good information. When you're using a corded tool, you don't want to use your corded tool if you've got some extra cord on this job site for today, with it in a coil. Same principle. So what we're going to do at this job site is, yep, we're going to take this, and what we're going to do is, instead of coiling it all around our bodies, is we're going to have this thing come out away from us in parallel. Okay, so we're doing this, setting this up, getting a little parallel action, kind of like that. Doesn't have to be perfect. Okay, but just something to, see that? See how we're doing that? To mitigate any potential. So in other words, if Mr. Emilio here, if he accidentally came in contact with a potential for whatever reason, and that potential bypasses, and it has happened, I'll tell you about a story, bypasses those resistors, this cord receives full primary power, and it will explode. And if it's all coiled up, then that creates that magnetic field, and we've got a worse problem than just the primary power exploding the cord. It's even, now we increase it, magnify it. Okay? So what we're going to do is we're going to phase this overhead line. And how we're going to do that is our hook probes, which are really bushing adapters, we're going to make an accessory change on our tool. So grab that bushing adapter, okay, and change it out. Now wait, Emilio, remember, we are very safe here in Imperial Irrigation District. And when we make an accessory change, Emilio and I, guess what we do? Because we know how electricity works, because we've seen this presentation and we share it throughout all of our crews in this company. So what Emilio and I are going to do through our safety training is we're going to, when we make an accessory change, we make a tool change, we make an equipment change, or Emilio, he's got swamp britches, he changes his pants. We're going to walk away from the potential. We're going to walk away a couple of steps from that electricity that right now is coupling with me and him right now. Because we know, measurably so, our work, when we're working hot, it's connecting with us right now. So we're going to take a couple of steps away to mitigate a possible scenario that only happens once in a lifetime. You guys get that? Because these things that are, these freaky things that are happening to folks around the country, they only happen to them once in a lifetime. Okay, think about that. All right, let's make the change, buddy. Any questions thus far? Is this okay training? Is it okay safety? Okay. I hope it's okay. My wife's from OK. She's from Oklahoma. And she's okay. We've been married 35 years. So she's okay. All right. Okay, Emilio. Okay, before you make contact, we don't want to come in contact with that cord, right? Okay? So stay away from your cords. And what we're going to do is, I got it ground, and you come into that hot bushing, that hot line above. That,
1B.
here, watch out, it's on your foot. Don't let it be on your foot. Okay, now make, H1B. Okay? What you got?
Nothing, I turned it off again.
Timed out? Okay.
So I leave it right there on 2K?
Okay, good question. Emilio's asking, does he leave it on 2K? Well, we know we're on 20,000 volts, so no. If he did leave it on 2K, it's in the wrong position. If your tools, whatever tools you use are in the wrong position, they're going to give you a funky reading. Just remember that, okay? If it gives you a funky reading, it doesn't mean the tool's broke. It means your mind's a little funky and you're not thinking right. So change it to the right reading, the right setting. Okay, got 25? Go ahead, 25. All right, go ahead and plug it in. See? Okay, got it all the way in. Yeah. Shove it. There you go.
There you go, 20,000.
Okay, 20,000 volts. Now what I'm going to do, remember we're at the middle, this middle overhead line in El Centro, California. This is the middle overhead line out of the three. So we're at a new job site. So the tool's working on a Light-on voltage source. We're going to phase. Our phases are hot. We also verify this new job site. Same day, new job site. We're going to verify that I'm mutually accountable to Emilio. Emilio's going to verify he's mutually accountable to me. Same day, but different job site. Okay? Super important. All right. I'm going to go to the other side of the cabinet or another cabinet. Plug in. What you get?
0.3.
0.3. Almost zero. The reason why it's not zero is because this cord, do you hear that buzz?
I hear the humming.
Yeah. There's a little bleed on that cord. There's about a 0.5 milliamp of current that flows through that cord at all times when you're using it. Okay? So we're phasing, so we know we're in phase. Now what we're going to do is, and this is important, safety, is whenever you high pot, whenever you phase, what you're going to do is you're going to go with the secondary probe to ground first. You don't need to do it this way. You could go the secondary probe off last. But what we want to do is we're going to do it in this sequence because we want the tool to speak to us and tell us when it's de-energized. So I'm going to the ground first with the secondary probe. Stay there. Now, Emilio knows that when he pulls that tool off, he knows that because of these resistors in the probe, he knows that that tool is going to take about 2 seconds to de-energize because of the resistors. It's not instant. It takes just a few seconds. But he's going to pull the meter head off last because he wants the tool to tell him that it's de-energized. You see the safety involved here? It's not that important. But all these little details, all these little things add up to the big picture. Because if these little things are important, then the big things become and are formulated to be important as well. And the little things add up to the big thing in your mind. You see what I'm saying? It's a culture, it's a consciousness. It's a mental thinking, right here, condition, okay? So all these little details are actually helping you when you get to another job site to think different. Your mind is different, so you're going to pay attention to all these different things, scenarios that could take place. Okay? All right, so go ahead and pull off, and let's see what happens. Let the tool talk. Took about 2 seconds. See? See how it works? Okay, did good. Okay, all right, you're done. You can turn it off, and then put your tool kind of like I have mine, okay, against the trailer. All right, real quick, do you all do any wireless phasing? Wireless phasing? Substation does? Do you all have any substation folks here? Do you want me to go, do you have time to go over some of the wireless phasing? Do you want to? Okay. All right, so Emilio and I are going to be phasing. Now, when we phase, you can use this tool, the PD800W. It starts phasing at 50 volts, and it phases up to 800 kV. So you can phase off capacitive test points. You can phase off overhead, underground, high side, low side of substation. Transmission, you can phase using the reference probe on transmission. You can take the meter probe and you can stick it in a light socket and verify what phase it is, if it's a match or not, from transmission to that receptacle. Okay? So it's kind of cool. It's a neat tool. It has two functions. The first function is actually what you were watching me do previously, and that was URD or OH, a voltage detector. So it does look at potential. That's the one function. The second function that it does, it has two jobs. The second job it does is it's a great phasing tool. When you phase, you put it in DEG for degrees. When you put it in degrees, the tool, right now you're telling it not to look at potential. Don't care about potential. When you tell it to go to degrees and look at the phase angle, that's what it looks at. Phase angle. It don't care about potential. That's why you can phase between transmission and that receptacle on the same circuit. Okay? Because they don't care about potential. All right. So what we're going to do is, this particular location is these two tools. They talk to each other up to 300 feet apart. RF signal. So I'm going to go to a 7200 overhead on a known A phase. Now, if I go with the reference on an A phase, then A phase is the reference because the reference probe is on it. Therefore, it's looking at the A phase as the first phase coming out of the generation plant. Okay? That's my reference. So if A phase is my reference, and Mr. Emilio he's touching capacitive test points, he's touching this overhead line, he's touching 200 volts, 20,000 volts, and I'm on 7,200 volts, and he gets a white light in zeros or close to zero, then he knows it's a match. There's no phase angle difference when you see zeros. And if it's a phase angle match, then it's an A phase because A is the reference. So if A is the reference, then the sequence is A, B, C. Pretty simple. If the sequence is A, B, C, A is the 0, B is the next phase out of sequence, that's 120 degrees, and it's a blue light. If I'm on a C phase, that's the second phase out of sequence, out of the 3, and that's going to be a red light, 240. 240 degrees out. 0, 120, 240, ABC. Okay, you guys get that? All right. So,
You want to have it on degree?
yeah,
Okay.
go ahead and put it on degrees. And Emilio, go ahead. You start on these capacitive test points over here. If this is energized, the reference probe has a white light. So it's letting you know it's energized, it's hot or not. You can use this as a hot or not tool on your capacitive test points if you wanted to. Okay, so that's energized. And what do you get? So Emilio gets a white light and he gets close to zeros. Now, if he was working out in the field, he could have a leading or lagging power factors, and he could be a few ticks off. Okay, in other words, he could be seeing 008. He could be seeing a circle is 360 degrees, that's back to your 0. He could be seeing 354, but it's close to 0, and he'll have a white light, 2 confirmations, it's the same phase. Good? Very good. You're good at this. You've only done this for 2 years. Okay? All right. Emilio, go ahead to the overhead line, 20,000 volts. See what you get. See that, Melissa? Okay, so guys, what phase is this? This overhead line, what phase? B phase. Yep, because A is the reference. So 120 out is the next phase out of sequence behind the A phase. Very good. Okay, come on over here. I don't know if this is going to work. Let's see. Okay. Trying to get to 240. See that? It's it's going back and forth, kind of clicking. So so we know this is a C phase because we identified A and B. It's going back and forth. If you have a situation like this, what you want to do is, it's getting confused, the meter head's getting confused, 0-ohm extension. Maybe it's a tight volt. Put a 0-ohm extension on it, get that meter head out of the confusion. It'll be more accurate for you. Okay? Good. All right, good job. There we go. It's sticking. Yeah, it's staying. So, so let's do this real quick. If I take that reference probe and I go to a C phase, now just think, don't overthink this. If I take the reference probe and go to a C phase becomes the reference, right? Okay? So if Emilio here takes his tool and touches a C phase, what's he going to see? White and 0. So the next phase, so now if C is our reference, our sequence is C, A, B. Correct? That's our sequence. C, A, B. So that means C is going to be 0. A, next out of sequence, is going to be 120 in blue light. C is going to be, B is going to be the red light, 240, because C is the reference. So let's see what happens. Okay, Emilio. White light 0. What phase is that?
C.
Yes. That's Spanish for yes.
C.
Okay? All right. You guys are pretty good at Spanish around here. All right. Go ahead to your overhead line. Overhead line, Emilio. Good eye. Good observe. See? There he goes. What phase is that? Second out of sequence, right? B phase. Very good, guys. Okay, go ahead over to our capacitive test points, Emilio. Okay, it's trying to get to the blue light, 120. Did you see that yellow light blinking? So that yellow light is designed to let you know if you're 20 degrees or more out of phase. So it's designed, if you're at a delta Y transformation, you'll be 30 degrees off from our readings. So instead of 120, you might see 150. If you see 150, yellow light is telling you at a delta Y. It's made to do that. Okay? Very good. All right, good. Did Emilio do a good job? Huh? Would you want him to be on your line crew? No. Okay.
Safety's picking him up.
All right. So, Mr. Cava, where's Mr. Cava? Cave, Mr. Cave? Not here. So, Emilio, can you walk around and that generator?
Yeah.
And there's a key. And if you take that key and just go to the off position. Thank you. So we're going to de-energize. We're going to de-energize, folks, and we're going to talk about some tool tech. Some tool tech now. We're doing tactical safety, and now we're going to go in some tool tech. And then we're going to get into psychological safety. Okay, real quick. On our wireless phaser, if you have a base unit, you simply take your base unit and you plug it into a receptacle at a substation. Typically that's where the folks do it. Or you do it here at the office or at your house, whatever you choose. And you're going to calibrate this with the dip switches in the back to where when you get the PD800W wireless phasing voltmeter and you make contact with an A phase, that tool, a known A phase, that tool is going to read zeros in a white light. So it's a one-time calibration. Once you calibrate the base unit, you just forget about it. You don't worry about it. Emilio, what he's going to do is he's going to go out to this job site and he's going to accurately map and tag. He's going to accurately make a tie. He's going to accurately phase. But this area that he is going to, he's not sure if the phase is what it says it is. So he's going to verify before you guys put a certain load on a certain phase to balance the load. He's got to be sure that he's sure that he's sure. So he's going to go to this location within your footprint. And he's going to go ahead and take a cell phone and the field unit and the PD800W meter. That's on it. Right here. PD800W meter. And this reference probe that's hanging up there. And what he's going to do is he's going to go to that location in California, Timbuktu. It's a pretty good place to go four-wheeling. And he's going to go ahead and make a phone call to the base unit. It's in this substation or at your house, whatever. And when he hears that grid data in the earpiece, beep, 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 he's going to turn on the Bluetooth. When he turns on the Bluetooth on a cell phone, his Bluetooth links up to the field unit. That light will be a white light here. That white light goes solid. This becomes his known A phase reference. Okay? Anywhere, as long as he has cell phone service. And then he has to be within 300 feet of these two antennas. And then when he touches any conductor, you call it what you want, underground, overhead, any potential, when he gets a white light in zeros, then that's an A phase. If he sees a blue light 120 close to it, he knows that's a B phase. Red light 240, he knows that's a C phase. That's it. Real simple. That's all it is to it. Not difficult. Okay? It's that easy. All right. Any questions? It's very simple. Okay. Now, real quick, battery operated high pot. Do you guys use our battery operated high potter? Okay. So you do?
Yeah, but not that one.
The gray box?
No, it's black.
Black, so that would be a smaller unit.
Yes.
It's not ours then. Okay, so this here uses 18 volt battery, Milwaukee or Makita. And what you're going to do is you're going to have your primary. It's going to be on a feed through, isolated, de-energized. We're going to high pot to the dip pole. We're going to high pot also the cable. It's de-energized and isolated. That's going to be going to that next pad mount. We're here because we want to, maybe it's new construction, and we want to verify there's no intentional or unintentional grounds on that primary before we throw the switch in. All right? So we're going to simply take, or you have a bad span and you want to quickly find the bad span without using AC source. This is a lot safer and a lot more efficient. When we find the bad span, then you can bring in your thumper and find where the fault is located. Okay? But until then, let's just isolate the span. So what we're going to do, this will be on your hot stick. You're back on your hot stick. You approach. You're going to have this to ground in that pad mount someplace. And as you approach, if something's energized, the horn goes off and warns you. Proximity. If nothing's energized, which is what you want, you're going to go ahead and plug it in, get your hot stick, turn this tool on. It steps up 18 volts to 8,000 volts DC. The needle goes up because it has to charge that cable within a few seconds. That needle goes down and stays down. That cable's good. And that cable does not have any intentional or unintentional grounds either. It's a good cable. If the cable's bad, the needle goes up and stays up, or it bounces. If that needle stays up maybe 20% off of zero, barely up but stays steady, the whole tool is telling you it's a long run and you got some bleed on the cable's still fine. Okay, so it's a real easy, efficient tool. Now, I don't know what you guys do. Any troubleshooters, partial power flickering lights you guys do? Anybody? Partial power flickering, do you? Okay. Now, do you guys use I don't know your tools exactly, do you guys use our ST800? No? All right, real quick, this is a must-have tool for your troubleshooters. This tool here, what this does is it sources up to 800 amps. The next competitor, the highest, is about 80 amps. So this goes 10 times, obviously, higher sourcing. So this does a better job, more efficient, better, and once you make your repair, you can retest, and you can find an issue that the homeowner won't find until maybe 2 or 3 years later, but you'll be proactive and preemptive because it sources so much amperage, so much load, that you'll find it before the homeowner calls you back. So this tool is really excellent. So that's the first function, is service testing. Again, there's videos on everything. My brother Joe Bierer, he did one on this, and he talks about all 5 functions. Service testing is one. The other function it has is with the STRCV. This is the service test receiver. This picks up the pulse. So now, if we want to take that home that's inside the trailer, that right bottom home where the ST is hanging on that can by this magnet right here on the back, that right bottom home, we want to pull out of service, keep everybody else in service. We come here in this pad mount, and all those cables, they're labeled, but we can't read the labels no more, or there is no label. We want to identify. This picks up the pulse. So now you can identify your secondaries and test your secondaries with the same tool. You also, with the same tool, can identify positively your feed in and feed out at the pad mount. That's the third function. You also can, with this tool, with the CT clamp attached right here, the interconnect cable goes into the back of this tool. It's more sensitive with the CT clamp, and now we can identify that cable in the ditch or in the manhole, energized or de-energized, with the same tool. There's 5 functions. It's very versatile, not expensive, and it's an awesome tool to have for troubleshooters. Okay? So watch the video. Everybody that gets these, they put them on all their troubleshooters' trucks because they're an awesome tool, and they learn that it is actually a great tool. Okay? And you guys can trial anything. Kava can set it up for you guys. We also have cable ID tools, and this one here does 3-phase. I didn't put the cables on it. I knew I was forgetting something today. But what this tool does is it's powered by two batteries. You got ground bonded. You've got A and B and C going on your conductors. They're isolated, de-energized. The far end is isolated and it's grounded. It's bonded to your concentrics and the ground. And then we've got a couple T's here, maybe a couple manholes in between. You can leave all that intact. Everything in between, you just keep connected. And what we're going to do is we're going to turn on the tool. We're going to look for continuity. You'll see the lights go continuity is good. A, B, and C has a path through the conductor, back to ground, back to the tool. Okay? And then what you're going to do is it puts 1 pulse on A, 2 on B, and 3 on C. And all you do is you go to your CT clamp, go to your receiver. When you see 1 pulse, you hear it, it's got a sound, and you see it, it's got a light. When you see 1 pulse, that's an A phase. You move the clamp to the next cable. When you see 2 pulses, 2 lights, and you hear it, that's a B phase. Go your last cable, you hear obviously now the 3, and you see the 3, that's a C phase. That's an easy tool to use for underground, okay? So that's kind of our tools. That's our tech tool, our tool tech. And now I want to talk to you about psychological safety. All right, you guys ready? Okay, this is the most important thing. Okay, Melissa, this is the most important thing. All right, so what we're going to do is talk about psychological safety. So doing this for 6 years around the country, coast to coast, you know, past the border. The thing that I've learned what's happening out in the field is guys are getting hurt because of a lack of not safety training, not a lack of going into classrooms, not a lack of field safety, not a lack of this and that regarding safety. What I have found is why folks are getting hurt is because they're not psychological safe. Their minds, their mindsets are not safe. There's so many things out there that are influencing or they try to influence your mind. We have politics, we have all these divisions, we have all these things. Maybe you're in debt and you're under pressure because of that debt, because you're living above your means and you want to make more and have more. And what happens is those things start controlling who you are meant to be. You're supposed to be your brother's keeper, your sister's keeper. That's what you're supposed to be, regardless of what job you do. You could be a janitor. That's what you're supposed to do. That is your calling, is to watch out for one another. Watch out for your families. Watch out for your loved ones. Watch out for your friends. That's what you're supposed to do. And all these things come in our mind and they take that supposed to do, and then we do things that we're not supposed to do, and that's where we get in trouble. Okay? So, psychological safety. Several years ago, there was a guy changing out a broke pole, and it was in Michigan. And they knew the conductors were hot. He was with his buddy. They knew the conductors were hot, and his buddy was pulling out the good pole with the boom, and 20-year journeyman lineman was in the truck at the exact same moment, getting some gear out of the truck. The boom hits the conductors. That 20-year journeyman lineman becomes energized. He gets smoked. His wife loses her husband. The kids lose their dad. That's it. I mean, there's no more to the story. Root cause analysis. All right, let's talk about root cause analysis. Remember we talked about how we are to be mutually accountable to each other on that job every single day, every single job, regardless of who's with you. It don't matter who's with you. That's not the point of being a lineman. It doesn't matter, okay? So what's happening out there is that we're not watching out for each other. So what happened the night before? Those two guys, one guy was working the boom, okay? One guy was in the truck. The boom hits the energized line. We're mutually accountable. The guy that was working the boom, was he mutually accountable at that moment when the other guy, the 20-year journeyman lineman, was in the truck? Was he mutually accountable at that moment on that job site for that guy that got smoked? Huh? Did he know where he was? Did he know where his boom was? Did he know where his guy was in reference to where his boom was? Did he know? He didn't have a clue, did he? Huh? So that guy that got smoked, he was 100% dead. So percentage-wise, how much mutual accountability did the guy have when he was working the boom? Because this guy is 100% dead. Did he have how much accountability mutually? Zero. You see how that works? 100% dead, zero mutual accountability. Okay? So think about it. They're friends. They worked together for a while. They're friends. They got to know each other. They got to know each other's families. The kids, they got to know the kids. The wives got to know each other's wives. So, you know, they share stories. They share their lives together. They share all these things together. Do you think that gentleman, that 20-year journeyman lineman that got smoked, do you think that he would want his friend, his partner, to have that weight on his shoulders for the rest of his life as he was able to enjoy his family, his kids, see him graduate, see him grow, see him get married, have grandchildren? Do you think he would want to have that weight on the guy's life, on the guy's shoulders the rest of his life as he lived his life? Do you think he would want that? So the question is, the guy that was in the truck, was he mutually accountable to the guy working the boom? Was he? Because the guy working the boom, think about it, the guy working the boom is 100% going to have that weight on his shoulders the rest of his life. 100%. So is that mutually accountable to the guy working the boom? No. Zero. You see how that works? See, we look at the accident, we look at the incident as the root cause analysis. But there's more to it than that. If we've got a crew, if the crew is 2 people, the crew is 3 people, then what happens is these root cause analyses are all part of who we are. Okay? It's not that's a particular piece of equipment. It's not because we had a lack of training. It's because we have a lack of psychological safety. We're thinking of other things. You see how that works? So I go out with Emilio. I go out with him. I'm a foreman. I'm Emilio's foreman. And I go out with him. And I come in the truck that morning and I'm half drunk. And we're going to go to this job site. I'm half drunk. Emilio doesn't know it. Driving to the job site, he realizes that I'm falling asleep, I stink a little bit, and it's like, man, I'm not on my game, because Emilio has worked with me before, he's seen me in action before, and he knows that I'm not on the game. He's suspect. Something's just up. And so we talk a little bit. He wakes me up. Hey, Brent, man, we're almost there. And he finds out that I was up all night. I was up all night with my friends from St. David, Arizona that I haven't seen in 20 years, and we had some beers together. Okay? So that night before, I knew I was on call. The night before, I knew that I was going to be working with one of you guys. The night before, was I personally preparing? Was I personally accountable to Emilio that night before? Was I? Nope. I wasn't at all. So that other line that we need to add to our tailboards, that other line that we need to add to our job brief is a line called, I am personally accountable. And I'm going to check it off. I am personally accountable, and I'm going to sign that piece of paper, that oath and that covenant, and that commitment to you all, that commitment to Mr. Emilio, that I am personally accountable to him that night before I was prepared to be with him that day of work or that call out. You guys get this? We need to be personally accountable. I have been around International Linemen's Rodeo with all these linemen. I've been around these hobnobbing with linemen, shoulders to shoulders, all around the country, and I hear things out of their mouths that are unbelievable. You know, you're not a lineman unless you could set a pole half drunk. They brag about it. I hear it. And guys, here's the thing. You know, we talk about behavior out in the field. We talk about taking care of these incidents and talking about things. But the thing that's been happening for 20 to 30 years, guess what? The severe incidences, folks losing arms, losing body parts, and death has flatlined for 30 years. It has not gone down. We are doing more safety. We're eating safety. We're walking around with a gut full of safety. All right? But it hasn't changed what? Here. We haven't changed. We still got our egos. We still got our pride. We still think we're cowboys. We think we're better than everybody else. And we think we're something else. Okay? Because we did an awesome job that day. Everybody claps their hands. Everybody knows it. And we really think that we're something else. But when you think you're something else, think about it. When you think you're something else, where's the safety that you're supposed to be thinking of? This is why guys are getting hurt. Several years ago, a guy was in a boom truck. He was in a bucket. He's in the bucket, and he goes up to the conductors to do some work. His partner is inside the cab. Okay? He gets stuck. He's going in the bucket. He gets stuck on some lower communication line. He doesn't pause. He doesn't say nothing. He's going to, on his own, he's going to be the cowboy. He's going to go all on his own. And he's going to work those hydraulics, build up pressure, and he's going to pop loose. Because he knows he could. But what he failed to do was failed to predict what would happen after he popped loose. He thought and he predicted he could pop loose, but he didn't predict properly what would happen after he popped loose. You see the difference? And he did exactly what he thought he was going to do and predicted. He was a good predictor. You guys are great predictors, all right? And he pop loose as he predicted. But what he failed to predict is that conductor that's just above him. Once he popped loose, he would pop loose just enough, that bucket, to where his arm would come in contact with the conductor, poof, loses his arm. The guy in the truck, did he have any mutual accountability to his buddy in the bucket at all? What about the guy in the bucket? Was he mutually accountable to the guy that wasn't watching and keeping an eye on him either? Did he have mutual accountability to the guy in the truck? Did he? You see what's going on? Another story. Guys, this is so important. This is what's happening. And it's so sad. Several years ago, there was a lineman that he was within 1 hour. Think about this. 1 hour of signing his first home with his brand new wife. He just topped out. He's just a journeyman lineman. He's making great money. He's at the top of his game. He's doing great. He's getting taken care of. He's got a wonderful woman, and he's going to sign his house in an hour. It's at the end of the day. He's hot. He's tired. He's hungry. He's thinking about his house. Was he thinking about safety? He's hot. He's tired. He's hungry. He's getting a house. Was he thinking about safety? No, he wasn't. And just an hour before, top of the game, hour before he signs a house, his one arm comes in contact with the conductor as he's holding the guide wire. He wakes up in the hospital. Both arms have already been amputated when he wakes up. Within 3 months, he loses the house, he loses his wife, and he loses his job. And he's down here. He was here, and he's down there. Think about it. How responsible is it for a lineman that gets married? Now think about this. Has wife, have a child. How responsible is that lineman? And he loses an arm because he's thinking of something else. His wife wants to have children. She wanted a husband that could throw and play ball with the kids. That's what she was looking for. She wanted a husband that could kick soccer, kick ball, football, go football with their kids. But he lost a leg because of step potential. He lost a leg, and he can't do that no more. How responsible was he to her? You think she's going to be, she's going to be very sad, very upset. But could she also get pissed off and angry? Because you guys got to have the responsibility for one another, for each other, to watch each other and truly don't be talking about it, just do it. And be your brother's keeper and your sister's keeper, because that person that has a wife that wants kids for the husband to play games with, he deserves to go home with all of his body parts, and you need to be mutually accountable and personally accountable the night before. All right? And guys, you are very responsible and accountable to your families. Do not take shortcuts and do not do things and let your gut and the things that are happening around you take precedence over safety. Okay? Just deal with it. All right. I got more, but we could go more, but that's enough. And you guys have any questions? Do you have any questions? Okay? That's all. Thank you.